Hello, and welcome to the problem session for Chapter 11, Cost Estimating and Allocating. I'm going to solve actually three problems, but the first two are going to be learning curve problems. There were no problems in your homework assignment in McGraw-Hill Connect that involve learning curves, and I think that's an oversight, but I couldn't go in and change it this semester because a student had already looked at the problems in Chapter 11. So I'm going to work two learning curve problems. One is from the back of the chapter, and the other one is from Lecture 22 notes, or Class 22 notes, where I described learning curves and listed a number of problems of my own design. So this first problem, though, is at the end of the chapter, problem number 1136. And one of the reasons I'm emphasizing learning curves in this problem session is because when I worked in industry, this was a very common thing in the aircraft industry in particular, of using learning curves to estimate cost for future production runs of a product. Learning curves are used where your volume is low. You're not producing widgets by the thousands an hour or something like that. You're producing big things like airplanes or houses or something that is a fairly standard product, but it's produced in fairly low volumes. Hundreds, maybe up to 1,000 a year, but most likely in the hundreds per year kind of category. Anyway, the learning curves, you should certainly have reviewed the lecture notes for class number 22, because these three problems that I'm going to work, are directly out of those lecture notes, and in particular the section on learning curves, but the entire chapter 11 is on cost estimating and allocation. And so, however, when I looked over all of your homework problems, and in fact I always work all the homework problems, I found that the other areas of the chapter were covered fairly well, except for learning curves. So that's why I'm working two out of the three problems here today that are learning curve problems. So, okay. So the Department of Navy estimates that the learning rate for shipbuilding is 80%. Now, what's the learning rate? The learning rate means every time you double production, the cost or the number of hours required to produce that next number is only 80% of the hour for the half number. So when you go from number 1 to number 2 takes 80% of what number 1 took. When you go from number 2 to number 4 takes 80% of what number 2 took, and so on. So the learning rate is the percent that required, basically the percent required in hours or dollars when the production number production unit number, I'll call it, doubles. Okay, and the improvement rate we call 1 minus the learning rate. So in this case, the learning rate is 80%. And in case you're given an improvement rate, that means the improvement rate was 20%. The improvement rate is 1 minus the learning rate, or 1 minus LR equals IR. Okay. Then we define something called S. S is the slope parameter of the learning curve. And you'll see how we use S in a minute, but S equals the log of the learning rate divided by the log of 2. And it turns out the author shows you in the textbook that if you plotted the hours or dollars on the vertical axis, the log of the hours or dollars on the vertical axis, and you plotted the log of the unit number on the horizontal axis, you'd get a straight line with a slope of S in that plot. So on log paper, it's the slope parameter of that particular plot. So in our problem here, this is a lot of background information, but in our problem, we're going to need S to solve this question. And S is equal to the log of 0.8, or 80%. Okay, you list it as a decimal, divided by the log of 2. It turns out that the log of a number less than 1 is going to be a negative number, and this turns out to be minus 0.0961 91 divided by, and then you've got the log of 2 here. Log of 2 is 0.30103. Let's see. There you go. And so when we do this math here, S will be equal to minus 0.32193. That's the division of the two log values. And since the numerator is negative, the denominator is positive, I'm going to get a negative number here. Okay, so the formula for the number of hours to build Unit 12, we know the number of hours, let's see, where is that given? Oh, it took 62 months, not hours, okay, to build unit number 1. If the first unit, that's going to be our T1 value. So the formula, again, from class 22 lecture notes or from your book, actually it is equation, I think 11.7, something like that. The formula is that the nth unit, T sub n, is equal to the first unit This is the number of hours, months, dollars, whatever it is. This is given in months, so this is going to be in months. The number of months produced to produce the 12th unit, the nth unit, is the number of months to produce the first unit times n to the s power. So now we've already calculated s here. And we know n is 12. That's what we're looking for. So this says T12 equals T1, which is 62 months. So let me just go ahead and put that here. 62 months to the s power, to the 0 minus 0.32193 power. And it turns out that I forgot the 12, the n. This is T1, I'm sorry, this is a mistake here. This is T1. And now I need to put in n, which is 12 to that power, to the minus 0.32193. So 12 to that power. So T12 equals 62. Well, this quantity here, 12 to that power, turns out to be 0.44934. And when we multiply that times this, we're going to get 27.9 months. So that's how long we expect it to take to produce unit number 12. I guess these are submarines, so they're pretty sophisticated products. So that is the solution to this particular problem. So it's pretty straightforward. We just have to find S and then execute this formula here, and we get the value. The next one is a bit more complicated, and so we'll go to that in a minute. And this problem comes off of the lecture notes for class 22. If you go down to the bottom, there's a number of problems stated down. Those are my own design problems, and as I said, you'll get a problem like one of these on the final exam, so that's why I'm going over it in somewhat detail at this particular point in time. So okay, the number of hours required to produce the first unit is 100 hours. Estimate the cumulative total number of hours to complete 200 units if the improvement rate is 13%. So the first thing I'm going to do is say, okay, that's the improvement rate. That's 13%. What's the learning rate? The learning rate is 1 minus the improvement rate, which means it's 87%. And then when I want to calculate S will be equal to the log of the learning rate divided by the log of 2. Which we can get now pretty easily. The log of 0.87 divided by log of 2, and this is the log of 0.87 is minus 0.06 0.481, and we already calculated the log of 0.2 before, or looked it up, 0.3103. And when we there's a 0 here, 30103, and when we do this calculation, we'll get S equals minus 0.20091. Now, we're asking for the cumulative total number of 2,200 units. Well, in the book, the author doesn't really give us any formula to get that. We would just have to go back to this formula here and calculate it for unit number 1, 2, 3, 4, all the way up to 200. That would give us the cumulative total number. Okay, that's this formula here. Calculate it again and again and again. But I have in my Class 22 notes in red ink an approximation formula. And that approximation formula I called LC1 formula, or formula number, or equation number, LC for learning curve, basically learning curve handout. Equation 1 is as follows. The cost for the cumulative cost for 200 units, or well, let's give it in general, N units, is C, which is the cost per unit, and I'll talk about that in a minute, times T1 divided by 1 plus S. Remember, there's our S, okay? And then that is multiplied by N plus 0.5 to the 1 plus S power minus 0.5 to the 1 plus S power. And that gives me an approximation of the cost to produce all N units. So there's the N here on the right-hand side of the equation. It's in this thing here. And then this is our first unit cost, which was 200. The number of hours was 200. Now, the C is the cost per unit of hour. But since we're not converting to cost, we're only working with hours. So I'll just say, since we only need hours, cumulative hours, C, that's this C here, equals 1. Just don't even, we can just basically drop it out of the equation. So what we're looking for here is C200. That is the cumulative cost for 200 units. And we'd like to get it without calculating the cost for unit 1, or number of hours for unit 1, number of hours for unit 2, 3, 4, all the way up to 200, and then adding them all up together. Of course, it would be easy to do that if you had an Excel spreadsheet, but I'm looking for a simpler way, and this approximation formula will give it to us. So this is equal to, C is 1, so I can just drop it out. And then T1 is the number of hours to produce the first unit, which was 100. Now, I'm going to do a little calculation aside here. What is 1 plus S? Okay, if S is minus 0.20091, then 1 plus S will be equal to 0.79909. All I did is add 1 to this to get that quantity, because I'm going to use that a lot in this equation. So the first thing I do is divide inside the first bracket T1 by 1 plus S, which is 0.79909. Close that bracket. We're going to multiply that times. Now N is 200, so we're going to have 200.5 to that power. 200.5 to the 0.79909 power, and then we have minus 0.5, 0.5 to that power, 0.79909, and then we close the bracket. So this equation came out of lecture number 22 in the red print. You go down to the bottom of the lecture, you'll see that formula. And then, so now I'm just going to plug into the formula and do the calculations. If I divide 100 by this, I get in the bracket 125.14277. I carried, 5 decimal places because I may be multiplying this times a big number, so I want to carry the decimal places. And it turns out that then this number here, 200.5 to the 0.79909 power, is 69.11886, and this number, 0.5 to that power, is, put that in parentheses and this in parentheses, 0.57471, and then close the bracket. If you do the subtraction and do the multiplication, you will end up with that C2000, this number comes down, 125.14277, and then this minus this. You can see 0.57 from 69 basically leaves me with 68.54389, and then when I do that multiplication, I get 8,577.8, and all of this is hours. So that's my solution to this. So the next problem is also from chapter 22, of course, and it is one of the homework problems. And you should see this problem again when you do the homework for chapter 11. And it says, when I accessed the homework assignment, it was problem number 10, but it may not be problem number 10 when you access your homework assignment, and the numbers may be slightly different. I'm sure they will be, because of the random nature of the algorithm in McGraw-Hill Connect. So the author says the delivered equipment cost for fully equipped CNC machining system is $4.4 million. So that's the C sub E, that's the equipment cost, is $4.4 million. Okay, that's a given piece of information. Then he says the direct cost factor for this particular cost estimating problem, The direct cost factor is, I'll just say DC factor, 1.52. And then he says the indirect cost factor is 0.39, and then he says further that estimate the total plant cost. So we're looking for total cost, CT. Okay. If the indirect cost factor applies to the total direct cost. So there's really basically two equations that involve the indirect cost factors. One is if it only applies to the major equipment, and that would be to the 1.4 million. The other is if it applies to all direct costs, that is this plus the indirect cost. So in this case, it applies to all of the equipment, and when that's the case, we use. So when this is the case, indirect cost applies to total direct cost. That means use equation 11.7. And equation 11.7 says C sub T equals, open bracket, C of major equipment, E, the author says, C of E, I put CE, I'll just take that off, C of E, times 1 plus the sum of the various direct cost factors. These are direct cost factors. Sometimes this 1.52 is broken down into several factors. In this case, it's just given as one big cost factor, so to speak. And then we close that bracket, and then we multiply that times 1 plus the factor for indirect cost. He calls it IC. I like to use IDC, but I'll stick with his notation, IC, indirect cost factor. Close parentheses. Okay, so, and then he says, don't give your answer in millions, write it out, so to speak. So C sub T will be equal to, now this is 4.4 million. So let's just put it as dollars, 4,400,000. Okay, that's $4.4 million. And then this is 1 plus that 1.52. And we'll close that bracket, open this bracket, and this is 1 plus the 0.39. So this is 1 plus 0.39. And so we'll take that one step further. C sub T will be equal to 4.40000, not point, 4,400,000 times 1 plus 1.52, that's 2.52. Close that bracket, and then multiply this times 1.39. Close that bracket. When you do all that, you end up with the number of dollars, this is dollars, 15,412,320. So that is the estimated total plant cost when your major equipment costs 4.4 million. Your sum of your direct cost factors is 1.52, and your indirect cost factor applies to all direct costs, not just to the equipment. So that means that this is taken out as a bracket. If the indirect cost only applies to the major equipment, you can add it in with the other direct cost factors. That would have been equation 11.10, I think. So that concludes this problem session. I wish you luck on chapter 11 homework. Thank you.